today we are here because we have organized an international workshop in environmental biotechnology, and this workshop has been organized in the context of Green Earth project.
So at Indrea Water we are specialized in the development of membranes and biologenic techniques that contribute also to the bioremediation, so to the reduction in the presence and concentrations of contaminants in wastewaters. So can really be a way of coordinating forces between what we do and what you do at the Green Earth project.
So understand how works the microbial communities are really important in order to achieve and hold a high removal efficiencies of these pollutants. So the collaboration in these kind of international projects as Green Earth project are really interesting in order to promote synergies to improve our techniques, our process, and to learn about the new information that other research institutes or even other companies and universities are promoting.
I think it's just critical to understand what the microbial communities are doing for bioremediation of soil. So microbes are capable of degrade organic compounds in soil naturally. So there are some species that are able to do that. I mean, and not only this, so they are also responsible for soil fertility, soil sustainability. They are able to degrade organic molecules into simple ones that are used by plants for growing. So they are also critical for the maintenance of food security also. So they are involved in multitude of processing soil.
When you have large areas in which you have contamination, probably in situ bioremediation using amendment plants to control the contamination will be the best option, because you have an increase of the fertility when you add amendments, and you have also a decrease of the bioavailability, that is the most important thing of the contaminant, is the heavy metal. So I think this can be a good technology and effective from the point of view of the economy, because it's not easy to use strong technologies for large areas.
In ecotoxicology research, what we do is to try to identify what are the key contaminants that are polluting or affecting ecosystems. So we can, through risk assessment approaches, narrow down this list of 50, 60 compounds up to a number of compounds that is really posing a risk for aquatic ecosystems. So it is a task of prioritization of compounds that then should be included in the programs of bioremediation. So that's one of the applications. And the second application is to look at what is the toxicity of the samples before the bioremediation process and the toxicity after the bioremediation process.
At the end, if you want to biodegrade a contaminant in soil, you need to know which microbes are able to do it. So to perform such process, for this you need to use these omics techniques like metagenomics, metaproteomics, in order to identify which microbes and how are they doing these processes.
Any research, any project like Green Earth will be a contribution to the state of the art of the subject, because we need more information, we need small experiments, we need large experiments, we need different scales, and I think you have the opportunity to do a lot of things and to contribute a lot in the state of the art.